Hello, so in this experiment I will be going over my science fair project titled Not Your Original Speaker. You will get to know why it's titled that later on. So the question I was asking here is, what is the effect of the number of magnets on the average amount of decibels produced through a paper speaker? In this experiment I wanted to explore the depths of magnets and speakers. I create a paper speaker that has magnets reinforcing it to create sound. It stretches the barriers of physics, but the result is something that'll amaze you. I mean, it's a lot of work, but at the end, it's awesome. And that's why, it's not really your traditional speaker, so that's why I titled it that. I will be measuring it 3, 4, 5, with 3, 4, and 5 magnets. So, what is a paper speaker? How does it work? It's not as easy as you think. It's a speaker. The speaker is just a coil of wire glued to a piece of paper, then placed around a permanent magnet. When the alternating current flows through the coiled wire, it is either attracted or repelled by the permanent magnet. So when I created this is the picture I got. So you have the paper speaker onto your right with the magnets under it, so you can hear the sound, and then that's connected to the amplifier on the R plus and R minus sides. And then that, in turn, is connected to a phone where you can play any tone or song or anything you'd like to play to hear the sound. So the materials, it's mainly just your craft, usually drawing, painting materials, that's all it is. And then you add some magnets, some magnet wires. Be careful of the magnets, they are very small and chippy. Just be careful of them, might need parental assistance. The double-sided foam tape, some craft glue, and some sandpaper to wipe off the insulation of the magnet wire. For the procedure, you cut 2 strips of paper, then wrap them around a stack of magnets. You would take one of the strips of paper out and then tape the stack and the paper together. Wrap a piece of magnet wire around the paper 50 times. I know it does seem long, but it's not that long actually. Cut the magnet wire from its roll. Take 2 business cards and fold them into M shapes. Space them out from the stack and paper. Then you'd place the stack onto a vocab card and use double-sided foam tape to attach them. And then in turn, touch all of that onto the plate, which you can color. And then take the 2 dangling sides of the magnet wire, plug them into the R plus and R minus sides of the amplifier, as I said earlier, and then play a beat. 1,000 hertz beat is preferable to see and measure it very clearly. And yeah. So my hypothesis was, if I use 5 magnets, then I would achieve an average of 50 decibels. My variables are as follows. The independent variable was the amount of magnets. The dependent variable was the average amount of decibels recorded. Any control was 3 magnets. I didn't say 1 or 2 because it's not really easy to hear them. For the average human ear, you can't really hear 1 or 2 magnets. I actually tested it out, trust me. As my results, look, you can tell there's a trend going up if you see the average. 3 magnets, 4 magnets, 5, 6, 7, 8, and so on. It'll go up, it'll increase. So when I tested out, I did all the averages, so that's that. The conclusion, I found that more magnets do indeed increase the amount of decibels. The data collected from my project supported my hypothesis that increasing the number of magnets would increase the number of decibels. Of course, my bibliography used to cite some notes and info on this. So I hope you did enjoy my project. It's a tough experience, but I really enjoyed it, and I hope you enjoy magnets more now than you did before. They're very fun to use, and yeah, so thanks for this experiment, and see you.